Okay, so we are going to be looking at lesson 3 on the Pythagorean theorem for unit 1. This is on page 9 in your workbooks. So the Pythagorean theorem is, which you guys, some of you might have already heard of this. We talk about this in Algebra 1 a little bit. This is going to be a squared plus b squared equals c squared. Okay, so what this is really saying is we're talking about a leg of our triangle squared plus the other leg of our triangle squared. And that's going to equal the hypotenuse squared. Okay, and sometimes we abbreviate hypotenuse HYP just for future reference. Okay, so we're looking at this triangle here. We're going to say that this right here is our C. So the side across from our right angle, so our longest side of our triangle is our hypotenuse. So we're going to I'm going to put that off to the side. So hypotenuse is the longest side. Okay, and whenever we're talking about the Pythagorean theorem works only with right triangles. So that's what this little box here means. This means that we have a right triangle because that triangle has a right angle, which is 90 degrees. So I'm going to abbreviate Pythagorean theorem to PT, and that only works with right triangles. Okay, so only working with right triangles. This information off to the side is very important. Okay, so we have our C. We're going to call this side B and this side A. In all honesty, it does not matter what side your legs are, so it doesn't matter which side's A and which side's B. But we just want to know that we have our legs of our triangle and then we have our hypotenuse, which is our longest side across from the right angle. All important information. So whenever we're looking at an example like example 1, it says, what does X represent in this triangle? So we're looking at X. Okay, and we want to know what that is representing. So what side? Is that representing a leg or is that representing the hypotenuse? So if you look, we're looking across from the 90-degree angle. That's going to be our longest side. So this is going to be our hypotenuse. Okay, then it says for part B of example 1, it says find the length of the missing side in simplest radical form. So that's what we've been doing by simplifying our radicals, and to the nearest tenth. So simplest radical form is considered our exact value, and nearest tenth is considered our approximate because we're rounding our decimal answer. Okay, so if we want to find the missing side length, what we have to do is we have to look back up at our formula. So we're going to take our leg. So one of our legs, it does not matter which. Let's just take the 5, and we're going to square that. So we have 5 squared plus our other leg, which is 12 squared. Okay, and that is equal to our hypotenuse squared. And our hypotenuse, we don't really know yet. We're going to figure that out, is X squared. Okay, so from here, really all we have to do is some math. So we have 5 squared, which is 25. We have 12 squared, which gives us 144. And we're saying that that is equal to X squared. Again, just doing a little bit of math here, we're going to add 25 and 144 to get 169. And that's going to be equal to X squared. And we've been talking about how to solve a quadratic like this. Since we have an X squared, we have to use the inverse and take the square root to get rid of that. And so we're going to do that on both sides. So once we do that, we get rid of the square and the square root, okay? And then we're going to say, well, the square root of 169 is 13. Now, I know I've been harping on the fact that we have to have that plus or minus sign, but here's the problem with an example like this. The only answer that makes sense is a positive 13 because you cannot have a negative 13 side length. You can't have a negative length. So the only answer that makes sense here is 13. So we're going to say the exact value is 13 because we didn't have to simplify a radical. So exact value is 13. The approximate value, again, we didn't have to round a decimal or anything. It was just a whole number. So our approximate value is also going to be 13. Okay. Moving on to example 2. This time it's asking us the same thing. What is x representing in this triangle? So if we're looking at our side length here, x, we want to know, is that the hypotenuse or is that a leg? And in this case, we're actually trying to solve to find the leg. Okay, if you look, the 6 is the number across from the 90-degree angle. And so that one is going to be our hypotenuse. If it helps to label, it might help to put an L for leg, okay, and an H for hypotenuse so you can keep everything straight. Okay, again, it says find the length of the missing side in simplest radical form and to the nearest tenth. So we're going to do the same thing we did in example 1, but this one's going to be a little different because we're no longer solving for the hypotenuse, we're solving for a leg. So I have one of my legs squared. It does not matter which one you start with, so let's just start with x, and we're going to square that. And then I have my other leg, so I'm going to add 3 squared. And that's going to equal my hypotenuse, which my hypotenuse is that 6. So that's going to equal 6 squared. So from here, again, we're just kind of going to do some math. So we have x squared plus, if we square 3, we get 9. And if we square 6, we get 36. Okay. Again, just going to do some math to solve for x. So we're going to subtract that 9 away. And we end up with x squared equals 25. From there, if you look back up at our example here, we ended up right here, and we took the square root on both sides to get rid of that square. Okay, and if I do that, the square root and the square go away. And I get x equals, and then we're going to find the square root of 25, and that is a perfect square. So we're going to say x is equal to 5. Actually, we messed up, or I messed up. Let's go back here. 36 minus 9 is not 25. Goodness gracious. X squared is equal to 36 minus 9 gives me 27. I'm sorry about that, guys. So if I go and I take the square root of 27, just like I did before, I get x equals. Now, 27 is not a perfect square, so it's not going to give us a whole number. We actually have to break that down. So x is going to be equal to the square root of 27. But we have to break down the square root of 27, so I'm going to do that over to the side. If I break that down, I can break it down to 9 and 3, with 3 being a prime number. So I'm going to break down 9 to get 3 and 3. And those are both prime. So then if I look for my pairs, I have a pair of 3s here, and I have this loner 3 here as well. Okay, so I'm going to end up with x is equal to one of my pairs. So 1 from my pair, 1, 3, is going to come outside. the radical. And then underneath the radical, I'm going to keep that loner 3. Okay, again, this would normally be plus or minus, but since we're talking about a side length, it has to just be the positive version. So our exact answer is the answer in simplest radical form, which is what we just did. So the exact answer is going to be 3 times the square root of 3. Okay, now the approximate answer, you're going to want to put 3 times the square root of 3 in your calculator. And what that gives you is 5.196, okay? And it tells us to the nearest tenth for the approximate answer. So tenth is 1 decimal place. So we look here, we have a 1, so we want to look at the number next to that. And since that is a 9, that's going to round that 1 up to a 2. So it's going to be 5.2, approximately 5.2 units. Okay. Now it also says for part C, so now we're jumping to part C here, it wants the exact perimeter. And perimeter is the distance around a shape. So it's all your side lengths added together. So if I add all of my side lengths together, I have 3, I have 3 root 3, and I have 6. So if I add all of that together, the only 2 things I can combine are the 3 and the 6 because they are like. So we have 9 plus 3 root 3. I cannot add the 9 and the 3 together to get 12 root 3. This 9 does not have a radical on it. So I can't combine them. They are not like terms. Okay, so all I have for my perimeter is 9 plus 3 root 3. And we can, honestly, we can label all of these just units. It doesn't tell us whether it's inches or centimeters or anything like that. So we can just say that all of these are units. Okay. Moving on to number 3. So we're doing the exact same thing again. We're looking for our value or what x is representing in our triangle. So x is across from the 90-degree angle. And so that means that it is our longest side. And so that means that x is our hypotenuse. Okay. Then for part B, it says find the length of the missing side. So we want to find x. We want to find it in simplest radical form, and we also want to find it to the nearest tenth. So if I want to find my side length, let's go ahead and label. I have a leg, I have another leg, and I have my hypotenuse. Okay, so I'm going to take my leg and square it, or one of my legs. It does not matter which one you start with. So let's say root 6 squared. Then we have plus our other leg squared is equal to our hypotenuse squared. Okay. So we've been talking about how to square radicals like this. So I am going to do this off to the side. I'm going to take root 6 times root 6. And whenever you do this, you take the outsides and you multiply those together, which is just 1. So really you don't even need to put that. And then you have inside the radical 6 times 6, which is 36. So if I take the square root of that, it's just going to give me 6, since 36 is a perfect square. So we have 6 plus, now we have to look at that 2 root 2. So I'm going to say 2 root 2 times 2 root 2. Okay. And for this, we take our outsides and we multiply those together. So we have 4. And then we take our insides and we multiply those together also. So we have 4 root 4. Now, with the 4 inside the radical, that is a perfect square again. And the perfect square of 4 is 2. So we have 4 times 2, which gives us 8. So I have 6 plus 8 equals x squared. At this point, we can just add our 8 and our 6 together, which gives us 14. And that's equal to x squared. And we're going to take the square root of that. Okay, so the square and the square root cancel out. If we break down 14, it breaks down to 7 and 2. Both of those are prime numbers. Since they're both prime, they just get multiplied and put back underneath the radical. There are no pairs. So our final answer is just going to be the square root of 14. Okay, that does not change. It's already simplified. So that is our exact answer, the square root of 14. Now, our approximate answer, we'd actually want to plug that into our calculators and say, well, what is the square root of 14? So if we do that, the square root of 14 is 3.741. Okay, and again, it says to the nearest tenth. So I want to look at my first decimal place. And since the 4 is less than 5, that 7 is going to remain the same. So it's just going to be 3.7. Again, we can use units as our measurement here. Because actually it does give us, it does give us our units. It says yards. So we're going to say yards. Excuse me. Okay, now for part C, I'm going to do that in a different color. But I want to make sure, let's see, let's do it just right here. The area, it says find the exact area. So area equals 1/2 base times height. And the base and the height have to be perpendicular, which means that they have to form a 90-degree angle. So the two sides that form the 90-degree angle are this side and this side. So we're going to use those two as our base and height. And it honestly does not matter which one's base and which one's height. So I'm going to erase some of this. Sorry, guys. Okay. So if we do that, we end up with area equals 1/2. Our base, I'm just going to say our base is 2√2. And our height is √6. Again, it does not matter what order you have those in. So I'm going to kind of forget about the 1/2 right now. And I'm going to focus, I'm just going to put that there. But I'm going to focus on the 2√2 times √6. So we know how to multiply. We did that here and here. We know how to multiply two radicals together. So we're going to take the 2 times that imaginary 1 in front. And that's going to give us 2. And then underneath our radical, we have 2 times 6, which is 12. Okay. Now, I want to take half of that. So what I really want to do is I just want to take half of the number that's out front. And half of that number is just 1√12. Okay. The only issue that we run into here is that the √12 is not simplified. So we want to break that down. You always want to try to break it down if you can. Okay, so we have 4 times 3. 3 is prime. 4 is not, so we break that down to 2 and 2. And if I do that, I have some pairs. So I have a pair of 2 here. And then I have this loner 3. So I actually end up with taking one of those pairs out, a 2 times 1, because I can't forget about that one here. And then underneath my radical, I have my loner 3. So it ends up just being 2√3 for my area. If you remember back to probably algebra and maybe a little bit of middle school math, whenever you're finding the area, you always have your units squared. That's how you would label. Okay. All right. Moving on to number 4. If we look at number 4, this looks like kind of a difficult problem. But really, we just need to break it apart. Okay. So if we break this apart, let's first look for x. We want to find x and y in simplest radical form. But let's first look at this x. So if I look at that triangle, this 90-degree angle tells me that this side also has a 90-degree angle. So I can say that this yellow triangle, and if you want to, you can like redraw it outside of everything so it's kind of easier to see. We have x, 7, and 5. We want to figure out which ones are our legs, which ones are our hypotenuse. So we have a leg here, we have a leg here, and we have our hypotenuse here because that is the side across from the 90-degree angle. Okay, so we're going to use Pythagorean theorem to find x. So we're going to say x squared plus, we have 5 squared as our other leg, is equal to our hypotenuse, or 7 squared. So we end up with x squared plus 25 is equal to 49. Now again, we can just solve this like a normal equation. We're going to subtract the 25 from both sides. And we get x squared is equal to 24. Now we want to go ahead and take the square root to get rid of that square. And whenever we do that, we're going to break down 24 because we end up with x equals the square root of 24. And that is not simplified. So I'm going to go ahead and break down this root of 24 over here. We can say 12 times 2. 2 is prime. 12 can break down to 4 and 3. 3 is prime. And 4 breaks down to 2 and 2. And that means that both of those 2's are prime. So we need to look for our pairs now. So we have a pair of 2's here. And then we have a loner 3 and a loner 2. So that means we bring one of our 2's from our pair outside the radical. And we leave the 3 and the 2 underneath the radical to get multiplied together. And once we do that, I'm going to move over here. We get x equals 2 root 6. So that is our value for x. You can go ahead and you can draw that or write that in. Okay, now it wants y. We already have a portion of y, but we don't have the entire thing. So we already have this portion, but we don't have this other side. So what I'm going to do is I'm going to use Pythagorean theorem again. Okay, and I'm going to go ahead and I'm going to name this just a random letter. I'm going to name it A. And I'm just going to find that particular portion. So let me redraw this in real quick. We already found the yellow side. Now we want to find that pink side. So at this point, I'm going to use what I know. I know this is a right angle, so that means that 9 must be my hypotenuse, and I'm going to redraw that triangle also. Make it a little easier to see. I have A, 9, and 2 root 6, which is what I found for my last triangle. So I have the 9 is the hypotenuse because it is a cross from that 90-degree angle. A, we're going to call leg. And we're also going to say that 2 root 6 is a leg. Okay. So we want to go ahead and put that into our Pythagorean theorem. We can say that 2 root 6 squared plus a squared is equal to 9 squared. Again, if we want to take that 2 root 6 times 2 root 6, I'm kind of running out of room here, but we're going to say 2 root 6 times 2 root 6. Okay, we take the ins, or the outsides, I'm sorry. So 2 times 2 is 4. And then we take and multiply the insides. So 6 times 6 is 36. Now the perfect square of 36 is 6. So we're going to say 4 times 6. And that's going to give me 24. So I end up with 24 plus a squared equals 9 times 9 is 81. Sorry, my son just walked into the room. Okay, so if you hear him, I'm sorry. We're going to subtract the 24 on both sides. And we get 81 minus 24 is 57. So we have a squared equals 57. We need to take the square root. Now, if you try to break 57 down, I don't think it breaks down at all. Let's see. Oh, wait, it does. It breaks down to 3 and 19. But 19 is actually prime and so is 3. So this is actually simplest form. So we have a is equal to the square root of 57. So we have the square root of 57. Now, that is not what y is equal to, because you still have this 5 over here that you have to add into that. So y is just going to be 5 plus the square root of 57. I'm sorry, that was a lot of work. So number 5, if we look at number 5, it's saying if we have a triangle and the triangle has side lengths of 4, 4, and 4 root 2. So I'm just going to draw my triangle. Okay. Actually, I probably shouldn't put that there yet because we don't know for sure if it is a right triangle. Okay. It's saying, well, is this a right triangle? Explain your reasoning. So we're going to use Pythagorean theorem to actually figure this out. So first things first, we need to figure out of 4, 4, and 4 root 2, which side is the longest? And 4 root 2 is actually our longest side. Okay, so that means that our legs are going to be 4 and 4. So we want to go ahead and put this into our Pythagorean theorem. We're going to say 4 squared plus 4 squared is equal to 4 root 2 squared. Okay, and we need to figure out if this is true. So 4 squared is 16. And then we have that 4 root 2 squared. So we're just going to multiply the together and see what that gives us. Okay, so 4 times 4 is 16. Then we have underneath our radical, we have 2 times 2, which is 4. And 4 is a perfect square, so that ends up being 16 times 2. Which gives us 32. Okay, so then 16 plus 16 is 32 as well. So since both sides are equal to each other, we can say that this is a right triangle. Yes, it is a right triangle. And you can say the Pythagorean theorem works for the triangle. Okay. So we also want to do the same thing with number 6. We're going to do the exact same process we just did. So we have, if the triangle has 5 root 2, 5 root 2, and 10 as its side lengths, is it a right triangle? So we need to figure out what our longest side is, and that's going to be our hypotenuse. And in this case, our longest side is 10. So we're going to name that our hypotenuse, and our 5 root 2s are going to be our side lengths or our leg lengths. And we're going to just plug this into the Pythagorean theorem just like we did in example 5. So we have 5 root 2 squared plus 5 root 2 squared equals, and then our hypotenuse squared. Okay, so we are going to figure out what 5 root 2 is whenever you square it. Okay, so we take 5 times 5 and we get 25. And then we take what's underneath our radical and multiply those together. So 2 times 2 is 4. And we need to check and see that 4 is a perfect square. So the perfect square of 4 is 2. So 25 times 2. And that gives us 50. So we have 50 here. We don't have to show all that work again because we have the 5 root 2 squared again. So that's just going to be 50 as well. And then 10 squared is 100. So if we add these 50s together, we get 100 is equal to 100. So again, yes, this is a right triangle because the Pythagorean theorem works for the triangle. Now, if both sides were not equal to each other, you will see examples like that too. If both sides were not equal to each other, that means that it would not be a right triangle. Okay, and that is it for day 1 of the Pythagorean theorem.